Good afternoon, dear students. In the last class, we learned what is Ohm's law based on an activity, right? So in the Ohm's law, we also learned one equation, right? What is that? Ohm's law is nothing but V is equal to IR, correct? This is what we learned from the Ohm's law. V is what? V is nothing but potential difference, and I is what? I is current, R is resistance, and I told that this resistance will be our next topic, and this resistance which is denoted by capital R. So here I just recall the Ohm's law diagram which we studied in the last class. Just look at the diagram. See, this is nothing but what? Battery. So here this X and Y indicates what? It is nothing but these, just we gave a name for these two terminals where voltmeter is connected. Now can you recall what is this R? This is an wire, right? Which wire? It is nichrome wire. That means we took an alloy here. So this wire is nothing but resistance. That is what our today's topic. We'll be learning everything about resistance in today's class. So this is resistance, and this is nothing ammeter which gives the current reading. And what is this V? V is nothing but which gives the voltage. So here we'll get potential difference reading, and this is a key, and as usual for the circuit diagram. Now here, what is this resistance? So in a electric circuit, you know that charges will flow. In other words, I can say the flow of current will take place. Current, right? Now, that flow of current will be resisted, will be controlled by some term that is nothing but resistance. Now, can I repeat what is the statement of resistance? See here, the property of the conductor. What is this conductor? In that Ohm's law experiment, that is nothing but the nichrome wire. So the property of the conductor to resist the flow of charges will be calling as resistance. So it is nothing but which resists the flow of charges is called as resistance. Now listen, later we'll get one more same name, that is nothing but resistor. Now here only I'll just inform you what is the resistor. See, resistor will call to that particular wire what we connected in that Ohm's law, nichrome wire, resistor. Now resistance is the property of that resistor. Understood? Now what does this resistor do? Resistor has a property which can resist the flow of charges in an electric circuit. That's it. Okay. So this is called as resistance. Now resistance, which is denoted by capital R, and the SI unit of resistance is nothing but ohm. The earlier activity what we learned in the Ohm's law. So this unit is named after that scientist, and which is denoted with this symbol, and this is called as what? Ohm. Okay. So this is important. As I told, all the SI units are important. You need to concentrate it on more. So we'll get it for 1 mark question. SI unit of resistance is ohm. Now we already know the Ohm's law equation. V is equal to IR. Correct. So once we know the equation, just we need to modify this equation to get R. Correct? No? That is nothing but R is equal to V by I is the resistance equation. That's all. See, you need to, without forgetting, you need to remember this formula, because everywhere when we are solving numerical problems in the next class, we'll begin with this one. Later we need to modify this one. So based on the question, we need to keep on modifying the main formula. So resistance formula we got here. Now let me define the same formula in terms of SI units. Okay. Now what is this R? Ohm. Potential difference as it is, that is volt. I is what? Current, that is nothing but ampere. Okay, ampere. So next is what? Now you may get a question, define 1 ohm. As I told, if you don't have any coefficient or a number here, we just need to assume that it is nothing but 1, right? So here our question is define 1 ohm. Now listen how you need to define. Since the question is based on the SI unit, you cannot use this term. That means you need to define using this formula, right? Now how can I define this 1 ohm? So it is nothing but potential difference will be always measured between two terminals, right? So the potential difference across two ends of a conductor is 1 volt, and the current through it is 1 ampere, right? Then 1 volt over 1 ampere is nothing but what? 1 ohm. Correct? No? So once again, I'll just write this question because it is there in your in-text. So since we have this question in in-text, this will be important for your exam. So V is what? Potential difference, which will be there between two terminals of a conductor. So we need to start the statement that is nothing but the potential difference across the two ends of conductor is 1 volt, and the current through it is 1 ampere. The same thing I'm writing in the statement form. So then when we have 1 volt divided by 1 ampere, of course the resistance will be 1 ohm, right? So then the resistance is 1 ohm. Now this is what the answer. If they ask what is resistance, you can write this one. If they ask what is 1 ohm, you need to define the formula based on SI unit. That's all. So this is all about this resistance. Now once again, here you need to concentrate again this formula. What is this? R is equal to V by I. Can I call this equation as R is directly proportional to potential difference and R is inversely proportional to current, right? So the same formula I can write in two different forms with particular to this potential difference and with this current. Now this is what you need to remember. Further we'll be learning with some other activities. Now we'll see relation between resistance and current. This one, I'm taking this one. So there is one main important point which you should remember. Okay, now what is that? That is nothing but as resistance in a circuit. If the resistance is more, that means if resistance is increasing, automatically current, you need to understand, I means what? Current will decrease. Understood? So as resistance increases, current will decrease, and this will happen vice versa. That means if current increases, then resistance will decrease. Okay, so if the resistance is doubled, then the current will be halved. So it keeps on going as a statement. So the next relation, it is nothing but we'll just compare this with Ohm's law, what we learned that activity. Now listen here, the graph of VI, what is VI? Potential difference and current in nichrome wire is always a straight line, which shows that as I increases through a wire, the potential difference will also increases linearly. Now listen, this is what we learned in the last class, Ohm's law. So this x-axis is what? This is a current. Now listen, whenever you are indicating x-axis and y-axis, you need to show the unit also. Current, that is I. Here what is this? Potential difference. First you need to mention the name potential difference, that is nothing but V, right? Yeah. So what we got? So in the textbook we have with the values, right? You can just observe that as potential difference increasing, the values of potential difference is increasing. Simultaneously we can also observe the value of current is increasing, and whatever we got, the straight line, it is nothing but what? It is the product of V by I. Now what is V by I? Coming back to this formula, resistance formula, R is equal to V by I, potential difference divided by what? Current. Now whatever we got, this linear line is nothing but resistance. Clear? So you will get a multiple choice question or direct to a 1 mark question, that is what type of a line we got in that Ohm's law graph. All you need to remember is what? Linear or a straight line. Clear? So this is the relation between resistance and current. Now there are some factors which depends on this resistance, or I can also say that factors on which resistance depends. Now we need to learn that one based on the activity. Now in this chapter we'll get number of activities. Once you just look at your textbook in all the chapters, especially in this physics, you will get number of activities. Based on that activity only we need to learn the theory. So from the examination point of view, 2 activities are important. They may ask any different kind of question, that is nothing but from Ohm's law activity, which we learned in the last class, and now what we are doing, that is factors on which resistance depends. So that is a one more activity. Clear? So now let us see activity, and the activity is nothing but 12.3. Pause the video, just read once what they are given procedure in the textbook, then watch this back. Now this is 12.3 activity. So I hope everyone read that procedure what they are given in the textbook. Now I'll just directly come to the experiment. See, here we have an electric circuit. Look at the circuit. We have a battery and key and a meter, and here we have two terminals. If you want, we can name it as X and Y, or I can just leave it as it is. So here I have a circuit diagram. So whenever we are conducting an experiment in physics, we should get one diagram with respect to that, or in chemistry also with respect to that, we should have one tabular column. That means what we are observing in the experiment, we need to note that, right? Later if you want, we'll get calculation, etc. Now we'll go with the tabular column. That means I have two columns here. The first one is cases, or I can also call this as trial number 1, trial number 2, trial number 3, and factors. And here at last result, that means what happens to the current reading in the ammeter. See, you need to learn this diagram also. And the activity of Ohm's law and the activity of this factors on which resistance depends, I'm not giving this in your classwork. So what you are learning in this video, make your own notes. Just you need to write as it is I'm doing, okay? So write that one. Now in the first case, here what I need to connect? I need to connect resistance. That is nothing but same thing I'm taking, that is nichrome wire, which is an alloy. Rather than taking any pure metal, I'm taking here nichrome. Now why we need to take alloy than pure metal? Because both are good conductors of electricity, right? But listen here, that means what we are taking? Alloy. Alloy has more resistivity. The same question you have in the textbook, I'll give a proper precise answer. You can read that one. So again I'm taking nichrome wire here. Now as I told, we'll be doing number of maybe some 4 trials. Now I took that nichrome wire, I'm connected here. I won't write here, I'll be writing below here, just to see. In the first case, this is case number 1. I'm taking a wire which I'm connecting here. Just you need to imagine, I'm connecting in between this terminal X and Y. So what is my first case? Some length. So length is denoted by L. I'm taking that alloy and connected between X and Y. So here, this is case number 1. So this factor should come here, that means here, length L. So it is nothing but just a serial number, okay? So length L. Now I came to know I got one value, let it be I1. I got one particular value. Now in my second case, I am taking the same nichrome wire, just I am increasing the length of the wire. Once again I will repeat, same alloy. That means same material, and the thickness is also same. What I am doing? In the second case, I am increasing the length of the wire. That means double of the first case. Clear? Now what I need to write on the factors? In the second case, I need to write thickness of wire is double. Now again as usual, I need to observe what happens in the ammeter, that means current reading. Now in the second case, we came to know that the current is off of the first reading. Understood? Later we'll just analyze. First we'll just note on the tabular column observation. Okay, so first case I took a wire and I note on the current value. In the second case, same wire with a double length and I got off of the first value. And in the third case, so in the third case, what I did, same as the first length, that is in our first case, same first case length, but what I did, so here I just increased the thickness. So the size has been increased with the same length. Now listen, what I did in the third case, thickness of the material has been increased with the same size. So which can I indicate it with A. A is nothing but area of cross section. Okay. Now here I saw that I got one value, let us name it as I3, which is more than I1. That means I got the value in ammeter more than our first value. Okay. Now this is our third case. Now fourth case. Now in the fourth case, all this is what? This is alloy, and what we took is nothing but nichrome wire. So here I'll just change the material. So material. So instead of nichrome wire, I took here copper wire. Now here I connected what? Copper wire. So here this is what you need to write. Material different, that is nothing but copper. So what I got more value than all of this above. That means let us name it as I4, which is more than this first value, or I can also tell as I3. Okay. Now this is the factors which we need to remember with the 4 cases. Once again I'll repeat. So this is an electric circuit diagram which contains two terminals. So in the first terminals, I took nichrome wire with some particular length. Then I took the reading in ammeter. I got one value. In the second one, I just double the length of first case and I got half of the value from the first reading. And in the third case, what I did, the same length, but I just increased the thickness, that means area of cross section. I got more value from the first one. And in the fourth case, I entirely changed the wire from nichrome to just an pure metal, that is copper, and I got more value when compared to the first trial. Okay, so this is what we learnt. Now from this again we need to conclude what are the points happened here. And before that, just let us recall these factors. Okay, so the factors are nothing but this resistance will depend upon length of a wire, thickness of a wire, 2 over, right? After thickness what we have? So length, thickness of a wire, this is not a thickness, no, this is length, correct. This one is length. Length of a wire is doubled, and this is third one is what? Thickness. It is nothing but what? Area of cross section. So 3 factors which we learned from this activity. And there is one more factor for all these things. Temperature should be constant. So this is one more factor, that is temperature should be constant. Let it be room temperature or below temperature. Now what happens? Listen, if temperature is more, automatically resistance will also increases. As I already told earlier, what happens when resistance increases? Current will decreases. Now vice versa. If temperature is low, what happens? Resistance will also decreases. If resistance decreases, what happens to the current? Current will increase. Now we want a proper flow of current, that means temperature should be constant so that these two cannot vary. So here all this condition will apply with a constant temperature. Now this is an important question for you, that is they will ask you for the 2 marks, list the factors on which resistance depends. Clear? What you need to write? You need to write only 4 factors, that is nothing but length of a wire, material, this one you need to name it as material of a wire. These both are same only, no? Length of a wire, and the second point is what? Thickness or area of cross section of a wire, and third one is material of a wire, and fourth point is what? Temperature of wire. Now from this experiment all you will get this 2 marks question. If not, they will ask something from this activity only. Okay, so now let us analyze what we learned from this activity. Now from this activity we can observe that current is inversely proportional to the thickness of wire. Now current is inversely proportional to thickness of wire means I need to write this as like this, no? I is inversely proportional to 1 by A, no, but we'll get I is directly proportional to A. This I'll just explain you after few moments, so that I'll get one equation. Based on that, it is easy for you to show how we got this one, that is I is inversely proportional to A. It is actually inversely proportional, but we get this equation. Clear? Now one more point, thinner of the wire, flow of charge is easy. Instead of saying this one, I can say a different point. Now what is that? Let me tell after this third point. What is the third point? See here, if thickness of the material increases, current flowing through it also increases. I'll take back this sheet. See here, third one, thickness if increases, what happened? We got more current value than the first case, no? Now from this what I can conclude? From this I can conclude that if thickness of a material is more, the flow of current will also be more. Now I can also say if thickness of a material is less, the flow of current will be less, no? Opposite to this statement. So thus that I can write in this second point. Clear? Now this I can write in the formula, that is nothing but R is inversely proportional to area of cross section. Okay, and the next one, as the length of material increases, current becomes half. Just to recall first 2 trials, what happened? So in the first trial, see, we took one particular length and I got one value. So in the second trial what I did? In the second trial I just increased, that means double of the first length, right? So what I got? Current is half. That means as length of this wire is increasing, what happens? Simultaneously the current will decreases. So from that I can conclude, so what I can do? I can conclude that as the length of a material increases, current will become half of it. That is nothing but More the length of a wire, more will be the resistance of wire. Why? If current decreases only when the resistance is more, no? That means as length increasing, resistance will also increase. As resistance increases, current will decreases. And this statement I can write it as R is directly proportional to L. And the last one, current can flow very easily if temperature of wire is less. This is not necessary, but you can remember temperature should be constant or below a little bit room temperature, so that we will get a proper value of current and resistance, as I just explained earlier. Okay, so that is this point. So these are the things which we need to learn from that activity. Now here what you need to remember, here all you need to remember is this equation. What is that? R is directly proportional to length, R is inversely proportional to area of cross section, and I just told, I'll repeat this one. So wait a moment. So we have our next topic from this equation. Now I'm going to derive one formula. Okay, so now what is that formula? So it is nothing but, listen here, length of a wire and area of a cross section of a wire is interrelated to each other. So you need to recall about what I'm talking now. I'm talking about these length and area of cross section. That means I need to take these two equations. Can I take now? So let me take these two equations now. So by taking those two equations, I can write R is directly proportional to L and R is inversely proportional to 1 by area of cross section. Understood? So how I got this one from earlier explanation. Now can I combine these two? Yes, I can combine these two, and I can write this as R is proportional to L and A. So this is nothing but R is directly proportional to length and R is inversely proportional to A. Understood? Now just to recall how we did in the Ohm's law experiment. Same thing, no? Some equation we got. So next is what? We need to remove this proportionality. So to remove the proportionality, what I need to do? So to remove this one, I need to add any constant term. So here I'll be adding a constant called as rho L by A. Now this is a symbol which you need to learn. This is not an alphabet from A to Z. This is just looks like elongated S, which is called as rho, R-H-O. Understood? Rho, which you need to write like this only. Don't just write small s. It looks like a S. It is nothing but elongated S. But while you are pronouncing, you need to tell it as rho, R-H-O. Clear? Now, this is R, that means resistance. This is length. This is area of cross section. And this will call it as resistivity. Understood? Now, quickly I'll tell what we learned. Resistor, which is a material or wire which has a property to resist the flow of current, we'll call it as resistance. So this is first term, this is second term. Next what we have, this is third one, resistivity. Now if the as defined resistor or a resistance or a resistivity, you need to write three different answers which you should know. Okay, a proper resistivity definition I'll give you later. Before that, once again we'll concentrate or we'll come back to this formula. R is equal to rho L by A. This we'll call it as resistivity, which is an important formula. Later, based on this formula, we're going to solve one problem. Now listen, in our problem, that means numericals, we'll get to calculate this resistivity. That means I need to take rho outside from this formula. That means I need to modify, I need to find out. So later we'll do that one. Now, what is a SI unit of resistance? It is nothing but ohm, no? Now, what is a SI unit of resistivity? So resistivity also have a SI unit, that is nothing but ohm meter. Understood? Now how we got ohm meter? This is also we can easily define with this expression. Resistance means what? Resistance is nothing but SI unit is nothing but what? Ohm. Now this one we need to find out. L is nothing but meter and area of cross section is meter square. Now I can cancel this meter with this one. All I left is 1 ohm and 1 meter. If I cross multiply these two, what I'll get? Ohm meter. So SI unit of resistivity is what? It is nothing but ohm meter. Clear? Now let us see. Okay, as I told, I need to verify that earlier we learned current is directly inversely proportional to, what was the statement we got? Here on they have I is directly proportional to A. How we got this one? Now let us see how we got that one. So we know the formula R is equal to resistivity L by A, right? And just take the formula of V is equal to Ohm's law, that is nothing but V is equal to IR. Take I outside, what is that? V by R, correct? So here V by R, here we have the value of resistance. Now can I replace this R with rho into L divided by A? So I will get I is equal to V divided by rho into L divided by A. If I modify this one, what I will get? I will get I is equal to V into A divided by rho into L. Correct? Now I can just write this as V by A. Can I call this as, just we need to use this technique, that is nothing but I is directly proportional to what? This potential difference, and this is nothing but area of cross section, and inversely proportional to this rho, that is nothing but resistivity and length. So since we are concentrating only on this A, that is what? Area of cross section, I'll take only this outside, this term, that is I equal to A, or in other words, I is directly proportional to area of cross section. Correct? I is directly proportional to area of cross section. So how we got this one? Current is inversely proportional, but later after the modification we will get I is equal to A. Understood? Now from the last page, all you want to remember is about R with respect to area of cross section and about R with respect to length, because based on those two we'll be deriving this main equation which contains resistivity. Further we'll modify based on the numerical problem. Now just let me discuss what is the definition of resistivity. Resistivity can be defined as a measure of the resisting power of a specified material to the flow of an electric current. So it is such a easy statement. Just to recall, as I told, we learned three almost similar terms, right? Resistor, resistance, resistivity. Now you need to understand one by one. Resistance is a material, that wire, which has a property resistor current, that we'll call it as resistance. Now to measure this resistance, we will call it as resistivity. In other words, we need to write it as a measure of the resisting power of a specified material to the flow of electric current. It is just a normal definition, but this is what you need to learn in terms of, or based on the formula. It is nothing but we can also call it as resistance of a conductor, or a resistivity of a conductor, which is the resistance of a conductor of unit length and unit area of cross section. Okay, so both are easy. Which one you can learn properly, you can use that one. If not, you can prefer this statement. Okay, now you know the meaning of resistivity, which is denoted by rho. Okay, this we are not indicating as R. R is nothing but resistance. Resistivity is denoted by a symbol called as rho with the SI unit ohm meter. Now you will get a question. Differentiate between resistance and resistivity. Can you guess any simple 3 points? No. First one, what you need to write? You need to write its definition. Resistance and resistivity. Second, you can easily write the symbol now, which is denoted by R, which is denoted by rho. And what you can write? Third, unit, SI unit, it is ohm, it is ohm meter. And fourth one, you can remember here, resistance we learned with some factors, right? So this will depend upon length and area of cross section. Which one? Resistance. And remember here, it is opposite to this one. That means resistivity does not depend upon length and area of cross section. Now listen, you just easily you can remember these 4 simple points. Now everything we learned about resistance. So once again I'll repeat, in the last class we learnt about Ohm's law. Now we started with resistance. You learnt about resistance, factors affecting the resistance with an activity, then some points under the relationship between I and R. Then you know this resistivity and its formula also, and you know the difference between these two. Now whatever we learnt based on this today's class, next we need to solve some numerical problems.